Welcome back everyone to this video lecture. In this one we'll be talking about chapter 3. We'll be talking about atoms. They're known as the building blocks of matter, but also what are atoms themselves made of. We are going to be skipping over a few sections that I want you to read through in your textbook. So section 1 says from philosophical idea to scientific theory. That's on pages 67 to 69. Read over that. It kind of has some general ideas. In there they're also going to be talking about the law of conservation of mass. They're going to be talking about the law of definite proportions, the law of multiple proportions, Dalton's atomic theory, and the modern atomic theory. We'll be seeing some little short video clips in class that hopefully will also explain that, but remember, for you A-looking people, you want to be reading those pages in your textbook. Also, something else to read through in your textbook are pages 72 to 76. There you're going to be seeing some more information about like how did we discover what the electron is, how did we discover about the nucleus, how did we discover about the strong nuclear force. And again, we'll be having a short discussion about these in class, but if you want more detailed information or you missed that class, check those pages. So before we hop into making calculations about the components of an atom, I just thought we'd review what an atom is. So if you remember back to the definition of an atom, it says something like an atom is the smallest particle that retains the chemical properties of an element. And here, look, it says 3 subatomic particles. So it's composed of 3 subatomic particles, and 2 of them have an electrical charge and 1 does not, or we call it electrically neutral. So the first and most important particle that we're going to talk about when we talk about atoms is the proton, represented by the letter P here, and it has a positive charge, so I give it the plus sign. The next a subatomic particle that we'll discuss is the neutron, and again N and 0 because this is the one that is electrically neutral, hence its name. And then we have the electron here, and it has a negative charge to it, represented by an E with a negative charge. Now the next thing I want to talk about is the specific location within an atom where these things are located. So notice here in the center we have the clump of all these protons and neutrons. This is called the nucleus. And again, this is where we've got the protons and neutrons. And I'm just going to start off right now talking about this is held together by something called a strong force. We'll discuss this more in class. Remember to ask me, what is the importance of the strong force? The other area of the atom that you need to be familiar with is this area on the outside here where the electrons are. And we call this area the electron cloud. And sometimes you'll hear us discuss it, kind of in the olden days we used to call it orbitals. And so electrons live in the electron cloud or the orbitals. They're distributed randomly around the nucleus, and they don't end up running off into the universe because they are attracted to the positive charge inside the nucleus. So one of the most fundamental ideas to know about atoms is to know about this thing called the atomic number. The atomic number is sometimes represented by this letter Z. So on some of our worksheets you'll see it says find Z, and that means the atomic number. And the atomic number is really important because it tells you the number of protons of each atom of that element. Remember how we defined element? It means that they're made up of many atoms, but all of those atoms have the same number of protons. And so when we talk about that, we're saying the atomic number. So it's going to be really important that as we go through this, if I tell you that an element has an atomic number of 7, I'm hoping right away from our element quiz you'll be like, okay, so we're talking about nitrogen. Or if it has an atomic number of 20, we're talking about calcium. And we need to go the other way as well. So if I said, hey, what is the atomic number for titanium? You would look for this abbreviation on your periodic table. You would look for the bold number next to it, and hopefully you would tell me that titanium's atoms have 22 protons in them. Okay, next slide. Okay, the second most important thing that you're going to need is this thing called the mass number here. And the mass number is equal to the number of protons plus the number of neutrons. It's always a whole number, and it's not on the periodic table, but I'll show you on the next slide how we can get there. So remember, in the nucleus, we have these things called protons, and we have these things called neutrons. I'm just drawing a 0 in there to say that they have no charge. So all of these things are added up. If you were to count all of them in the nucleus, all of the subatomic particles, you would come up with something just called the mass number. On the other hand, if we just looked at these things called protons with a positive charge, we would be just determining the atomic number. So please keep these last two slides straight in your brain. So here on this slide, we're going to work towards being able to identify the number of protons, number of electrons, number of neutrons. And so to find the number of protons, remember we can look at the atomic number. To find the number of electrons, and this is in a neutral atom, we can also look to the atomic number. And we'll talk about this more in a minute, but this is only for neutral atoms. Okay, and the number of neutrons we're going to find by taking the mass number and then subtracting the number of protons, which we know via the atomic number. So our first example is if I asked you to find the number of protons, neutrons, and electrons in calcium, how would we go about doing that? Well, when I look at calcium on the periodic table, the first number that stands out to me should be 20, and this is known as the atomic number. So right away, this number can tell us the number of protons and the number of electrons. So right away, I can say that I have 20 protons and 20 electrons if it's a neutral atom. Okay? Now we still need to find the number of neutrons, though. So let's go ahead and look at the atomic mass that I have here for calcium. And notice that for calcium it's like 40.0, I'm looking back at the periodic table, 78. So what we want to do is we want to round this to a whole number, because remember on the last slide we said the mass number needs to, I forgot that up here, needs to be a whole number. So I'm going to round this to just 40 because it rounds closest to 40. So now to find this number of neutrons, I'm going to take the mass number minus the number of protons. So here's my mass number now. My number of protons, we already said was 20 up here, minus 20. So now I know that I have 20 neutrons. Now here on this slide we're going to do two separate problems. The first one we're going to start off with is if I gave you lithium as an element and I wanted to know how many protons, neutrons, and electrons does a typical atom of lithium have. I'm hoping the first thing you would do is you would look for the atomic number, and again that atomic number would tell you the number of protons and electrons. Then after that use the atomic mass number to help determine the mass number and therefore then the number of protons. Go ahead, take a minute, answer this question yourself, hit the pause button and you'll see the answer shortly. Okay, so the way that I solved this first one is first I looked at the periodic table for lithium. I found that it has an atomic number of 3. Right away that told me that the number of protons was 3 and that the number of electrons would also be 3 if the atom was electrically neutral. The tough part, as I mentioned, was going to be finding the atomic mass. So when I looked at the periodic table, I saw that it had a mass of 6.941. So from the last slide, I hope you remember that it needed to be a whole number, so I'm going to round this. So 7 here is going to be my mass number. I'm going to take the mass number over here, minus the number of protons, and this gives me 4 neutrons. So my final answer for this one is that an atom of lithium has 3 protons, 4 neutrons, and 3 electrons. Now on this next problem here, I'm not going to tell you what the atom is. I'm obviously asking you what is the element. It's going to have 29 protons, and then also determine the number of neutrons and electrons. Again, go ahead, pause it, and you'll see the answer here in a second. So this time I'm hoping that you were able to quickly look at the periodic table for the number 29, determine that that element was copper with a symbol Cu. So again, the atomic number quickly will tell you that it has the number of protons of 29 and number of electrons of 29. The tough part again was using the atomic mass to determine the number of neutrons. So here I looked at the atomic mass for copper and it was 63.5. Again, we need a whole number, so when we round that, this time it gets rounded up to 64. I take 64, I minus 29. You might be wondering, where did I get this number? Well, the number of protons, remember, we take the mass number minus the number of protons, and then this gives us 35 neutrons. So our answer here is that it's copper with 29 protons, 35 neutrons, and 29 electrons.